our group consists of Sophia, Jingru, and Yushin.
We investigated how temperature, concentration of reagents, and particle size
affect the rate of corrosion of the two limestone structures, the Taj Mahal and the Column. The city of Rome in Italy experienced warm, dry summers and cold, humid winters. Above half of the year, from November to the next April, is in cool temperatures under 20 degrees Celsius, while the other half above 20 degrees Celsius. The average temperature of a year is about 17 degrees Celsius. Whereas in Uttar Pradesh in India, where the Taj Mahal is at, the climate varies from below 10 degrees Celsius in cold winters to 45 degrees Celsius during hot summers. However, the temperature is about 10 degrees Celsius higher in Uttar Pradesh than in Italy during summers. The average temperature of a year is around 32 to 40 degrees Celsius. Therefore, due to Uttar Pradesh's geographical location, which is nearer to the equator, it is a hotter city than Rome. Rome generally has a healthy quality of air, free from harmful pollutants which mix with precipitate to form acid rain. Carbon emissions has reduced constantly due to government efforts. Rainfall is quite low at average 837.3 mm of rainfall per year, with reactants being relatively mild. Acid rain may still prevail in Rome but causes slower and less damaging corrosion. Next, India's economy is heavily reliant on industry and agriculture, which has caused more pollutants to be released. The tropical climate in India contributes to faster rate of reaction. Therefore, the concentration of the reaction is higher, hence there is a faster rate of corrosion.
Taj Mahal is a 73-meter-high monument with a base length of 296 meters and a width of 111 meters, while the Colosseum is 50 meters high with base length of 189 meters with width of 156 meters. However, the Colosseum has a center arena which is 88 meters by 55 meters. We have excluded the lower levels of the Colosseum because acid rain will first corrode the first few levels of the Colosseum. Taj Mahal is approximately 2370000 cubic meters with total surface area of 22100 square meters. The Colosseum has a total exposed surface area of 13300 square meters with a volume of 1320000 cubic meters. As such, the surface area to volume ratio of Taj Mahal to Colosseum is 1.2:1, and Taj Mahal has a larger surface area. First, we set up the downwards water displacement method with the volume of gas starting at 0 cm3. Then we put 10 grams of eggshells in the conical flask and start timing when the vinegar is poured in the conical flask and the rubber bung is put on. The amount of gas collected is recorded at every 10 seconds interval to ensure a more reliable and accurate result, instead of assuming the rate of reaction is the same throughout. The timing will stop when the volume of gas has collected reached 60 cm3.
For temperature, we use 7 degrees Celsius for one setup to simulate the average temperature condition in Italy and 45 degrees Celsius for another to simulate the hottest temperature in Uttar Pradesh, as a larger difference will produce a more accurate result based on research. Ice water and warm water was put in a beaker where the conical flask is in. For concentration of reagents, we use 2 different concentrations of vinegar solution in the experiment, one being filled with 40 ml of vinegar and other with 20 ml of water, 20 ml of vinegar. The more concentrated solution is to simulate the worst air quality in India and diluted to simulate better air quality in Italy.
We used cracked eggshells of about 2 cm square in one setup to stimulate Taj Mahal's surface area exposed to acid rain and 1 cm square to stimulate Colosseum's surface area exposed to acid rain, which are in a ratio of 1.2:1. And we have rounded up the numbers so that a larger difference will produce a more accurate result based on research.
The graphs as shown above shows the increase in volume of carbon dioxide produced every 10 seconds, for both temperatures until it reaches 60 cubic meters. As you can see, the reaction at a lower temperature took a longer time to produce 60 cubic meters of carbon dioxide. The reaction at 70 degrees Celsius took 82 seconds, while the reaction at 45 degrees Celsius took 43 seconds. To find the rate of reaction, we consider the rate at every 10 seconds. Hence, the average rate of reaction for the setup at 17 degrees Celsius is 0.547 cubic meters per second, while the average rate of reaction for the setup at 45 degrees Celsius is 1.08 cubic meters per second. For a difference of 28 degrees Celsius, the difference in rate of reaction will be 0.533 cubic meters per second. If we use the average temperature of India and Italy to calculate, which is 35 degrees Celsius and 70 degrees Celsius respectively, the difference should be about 0.343 cubic meters per second for an 18 degrees Celsius difference. Hence, the estimated rate of reaction of the Colosseum will be 0.547 cubic meters per second, while the estimated rate of reaction of Taj Mahal will be 0.890 cubic meters per second. Therefore, we concluded that as temperature increases, the rate of reaction also increases, which is why the Taj Mahal has a faster rate of corrosion than the Colosseum.
The graph as shown above shows the increase in volume of carbon dioxide produced for both temperatures until it reaches 66 cm3. Hence, we found out that the reaction with 9 cm square of eggshells took a longer time to produce 60 cm3 of carbon dioxide. Reaction with 9 cm square of eggshells took 24 seconds to produce 60 cm3 of carbon dioxide, while reaction with 4 cm square of eggshells took 15 seconds to produce 60 cm3 of carbon dioxide. Hence, the average rate of reaction for the setup with 9 cm square of eggshells is 0.833 cm3 per second, while the average rate of reaction for the setup with 4 cm square of eggshells is 1.33 cm3 per second. Assuming that the rate of reaction is constant throughout, when we use the average rate of corrosion and total exposed surface area to volume ratio to calculate, the estimated rate of reaction of colosseum is 0.833 cm3 per second, while the estimated rate of reaction of Taj Mahal is 1.33 cm3 per second. Therefore, we concluded that as particle size increases, the total exposed surface area to volume ratio increases, so the faster rate of reaction also increases, which is why Taj Mahal has a faster rate of corrosion than the Colosseum.
Next, the graph shows the difference in the reaction time taken for the carbon dioxide to reach 60 cm3 in both solutions. The undiluted has a faster reaction as compared to the diluted. Here's a table of the interval recording of the diluted solution. It has an average reaction rate of 0.308 cm3 of carbon dioxide per second. Here's another table showing the interval recording of the undiluted solution. It has an average rate of reaction of 0.789 cm3 of carbon dioxide per second. Consolidating our results, the undiluted has a faster reaction as compared to the diluted. Bringing back to the area of our research, the undiluted was meant to simulate the acidity of air in India and the diluted to simulate Italy. Therefore, based on our research and our results, it is safe to conclude that the rate of corrosion of the Taj Mahal will be faster than that of the Colosseum due to the presence of more acidic elements in the air.
95% of the eggshells contain calcium carbonate, while only 5% of the vinegar contained ethanoic acid. Calcium carbonate in the eggshells reacted with ethanoic acid in the vinegar to produce calcium ethanoate, water, and carbon dioxide. During the process of reaction, calcium ions and carbonate ions from calcium carbonate and ethanoic ions and hydrogen ions from ethanoic acid are in continuous motion and collides with one another. Calcium ions and ethanoic ions will then form calcium ethanoate, while hydrogen ions and carbonate ions form water and carbon dioxide. When the temperature increases, calcium ions and carbonate ions from the calcium carbonate and ethanoic ions and hydrogen ions from ethanoic acid gain more kinetic energy from the heat, which causes the average kinetic energy of the ions to increase. This causes the ions to move faster in all directions, and the fraction of colliding calcium ions with ethanoic ions with energy equal or greater than the activation energy to increase. Hence, the frequency of effective collision between calcium ions and ethanoic ions increases, allowing more calcium ethanoate to be formed along with water and carbon dioxide molecules, speeding up the reaction.
Concentration of vinegar increases, the amount of acid to molecule per volume is higher. Hence, the chances of frequency of collisions between calcium carbonate and acetic acid molecule increases. As the frequency of effective collision increases, it allows more calcium acetic to be formed along with water and carbon dioxide molecules, resulting in a higher rate of reaction.
To find out the rate of reaction considering these three factors, we took the average rate of reaction that is calculated from each factor, with the rate of corrosion in India being 1.003 cubic meters per second and Italy being 0.563 cubic meter per second. The rate of corrosion in India is